Gotten this far, one could wonder, but how do you get energy from the breaking of an atom? Watch this video to figure it out. Let's start from the very beginning, how atomic fission works. The main combustible of a nuclear power plant is uranium-235. This material is stable, so much so that it can even be touched with your bare hands. But if you give him an extra neutron, it becomes uranium-236, which is highly unstable and immediately splits up in barium, krypton, and 3 neutrons. Now if we try to make a sum of the masses of barium plus krypton plus 3 neutrons, the outcome would be ever so slightly lower than the mass of uranium-236. This is because part of that mass transformed into thermic energy during the fission. The potential of nuclear energy lays within those 3 neutrons released by the fission of uranium-236. Those will in fact hit 3 more atoms of uranium-235, which will release 3 neutrons each, starting a fast escalating chain reaction. So the objective of nuclear power plants is to use the thermic energy released by the fission of uranium-236 to generate electric energy. Here's how. Inside the core, where all of this goes down, we find uranium-235 bars, immersed in heavy water, D2O, under very high pressures, keeping the water from evaporating.
The reason for this is that according to a theory formulated by Fermi, neutrons only interact with atoms if slowed down, and heavy water is able to do so. Keeping the uranium bars away from each other, there are control bars made out of graphite and cadmium. The control bars can be lifted or lowered based on the amount of energy that requires to be generated. The purpose of the control bars is to absorb the excess neutrons to prevent accumulation of heat. In contact with the heavy water is a pipe, and inside the pipe flows regular water which evaporates, absorbing the heat. The high pressure water vapors keeps running in the pipe, reaching a turbine which generates mechanical energy that gets converted to electricity energy from an alternator. The gas is then turned back in water with the use of a condenser with cold water from rivers or lakes, and is then brought back into the pipe and starts back the cycle. All this starts off from a radioactive material outside of the core that emits neutrons toward the uranium bars. As a matter of fact, the water used to move the turbine is radioactive because neutrons emitted by radioactive material courses through it. The nuclear waters from fissions are left underwater for the entire of 5 years because water can absorb part of the radioactivity. After that, it is poured out and stored in a special containment in a hole around 450 meters underground.